Okay, in this video, we're going to look at how to deal with phase changes. If we have something changing, a substance changing temperature, but as it moves from one temperature to another, it actually undergoes a phase change, either from solid to liquid, liquid to gas, or by absorbing energy, or by releasing energy and going from gas to liquid or liquid to solid. So a couple quick tips before we look at some practice problems. This is something you should always write down at the top of your quiz or your test. So write your solid, your liquid, and your gas, and then arrows indicating phase change. So from solid to liquid, liquid to gas, and then back the other way, gas to liquid, liquid to solid. So to calculate our energy, either absorbed or lost during a phase change, we need to use our delta H whatever. There's a couple different delta H's we need to use. So when going from solid to liquid, this one's kind of confusing because it doesn't, sort of counterintuitive. But from solid to liquid, we need to use delta H fusion, so which is abbreviated to FUS. When going from liquid to gas, we need to use our delta H vap for vaporization. So that makes sense. Then when moving from gas to liquid, we need to use our delta H condensation, abbreviated COND, delta H cond, which makes sense. Going from gas to a liquid, that process is called condensation. Then when we're going from liquid to solid, it's delta H solid for delta H solidification. Now, there is a relationship between the delta H's that move, or the delta H's, so our delta H fusion and our delta H solid are going to be related. Our delta H vap and our delta H cond are going to be related. So our delta H fusion is going to be absorbing energy to go from a solid phase to a liquid phase. That is going to be equal to the amount of energy released by delta H solid to go from liquid to a solid. So remember, in thermochemistry, our pluses and our minuses, for the most part, just symbolize whether we're absorbing energy or releasing energy. Our negatives are going to equal a release of energy. Oops, let's make that so it's readable. Is a release of energy or an exothermic reaction. Positive is going to be an absorption of energy or an endothermic reaction. Okay, so our energy absorbed by H fusion, because this would be a plus essentially, our delta H fusion, the energy absorbed to go from solid to liquid, is equal to the amount of energy released to go from liquid to solid. Same thing going between liquid and gas and liquid. Our delta H vap, the amount of energy absorbed by our delta H vap, and you don't have to write the positive number, but just so we can better visualize that we're absorbing energy, is equal to the amount of energy lost by delta H cond. Okay? So those are some important things to keep in mind. So we can get rid of this. When we are working with these delta H's, oftentimes they're going to be in combination with our Q equals MCAT equation. So remember, our Q equals MCAT we're going to use only when we're in a single phase. Our delta H fusion, solid, vaporization, and condensation we're going to use when we're changing phases. So when we're going to combine them is when we're moving between two temperatures in which we have a single phase and a phase change involved. So for example, here's my graph. If I have water, and I'm taking water from -5 degrees Celsius to 102 degrees Celsius. If I was to plot that on this graph, it would look like this. So that would be my -5. I'd increase, so this is my -5 degrees, because this is my temperature. So my -5 degrees Celsius in degrees Celsius. Then when I get to 0 degrees, my temperature is going to level off. Because when we have a phase change, we're still adding energy. In this case, we're adding heat energy. So I'm still adding energy to my water to make my water increase in temperature from -5 to 0. But when I get to 0, I'm going to undergo a phase change because 0 is my melting point of water. Now, instead of the energy going to make my temperature rise by making my molecules vibrate, that energy is going to go to breaking bonds, to phase change from, so this would be my solid, right, because I'm below freezing point, and this would be my energy required to go from solid to liquid. Then once I'm totally at my liquid phase, and I've completely changed to a liquid, then my temperature is going to rise again. My temperature is going to rise until I get to 100 degrees Celsius, which is my boiling point. And once I get to a boiling point, again, my temperature is going to level off. So this increase in temperature here is my liquid phase. This plateau right here, where my temperature doesn't change, is where I go from liquid to gas. Once enough bonds are broken, my temperature is able to start to rise again, and my temperature increases to 102 degrees Celsius, in which my water is going to be in a gas phase. So if I was to have to calculate the energy involved in this entire process, going from -5 degrees Celsius to 102 degrees Celsius, I would have to use my Q here. Q equals MCAT for my solid phase, my Q equals MCAT for my liquid phase, and my Q equals MCAT for my gas phase. At my phase changes, kind of color code these here maybe. At my phase changes, since I'm going up, I'm going -5 to 102, so I'm adding energy. At my liquid to gas phase, I would use my delta H VAP. And at my solid to liquid phase, I would use my delta H fusion. If I was coming back down, so if I was going from 102, if I started at 102 and went to -5 degrees Celsius, instead of using HVAP at this phase change between my liquid and gas, since I'm now going from gas to liquid, I would use my delta H condensation, which if I wasn't given my delta H condensation, I would just put a negative on the value that I was given for delta H VAP. And then as I continue to come back down, I'm going to use my delta H solid as I go from a liquid to a solid. Again, as I'm moving from 102 degrees Celsius to -5 degrees Celsius. And again, if I wasn't given my delta H solid, I could just use my negative delta H fusion. So it'd be the same number, just it would have a negative value instead of a positive. Because when I have a negative, I'm releasing heat. When I have a positive value, I'm absorbing heat. So this is pretty much the breakdown of how I would do this equation. From if I had to find the total energy for this temperature change of water from -5 to 102 degrees Celsius, I would have to take my Q of my solid phase plus, and again, I'm going from -5 to 102, so I'm working up, I'm absorbing energy. The Q of my solid phase plus my delta H fusion plus the Q of my liquid phase. I'm going to run out of room here. The Q of my liquid phase plus my delta H VAP plus the Q of my gas phase. So I'd find each one of those pieces, add them all up, and I would get the total energy involved as I move water from -5 degrees Celsius to 102 degrees Celsius. So the next video we're actually going to do a practice problem, but this is just some background information on how to approach these problems and what to keep in mind as you solve them.